In this video, we're going to take a look at some of the exponent rules and then continue them in another video. So the first rule we want to talk about is the product property. So the product property states that when you have like bases, like these both are x, and they have powers on them, you can add those together when they're being multiplied together. So see how x to the m power multiplied by another x to the n power would equal x to the m plus n power. So let's write out a regular kind of example. So if we have 2 cubed times 2 squared, you want to think of what those exponents mean. So when you have a power of 3, it means that you're going to write that times itself 3 times. So I'm going to write this first 2 in purple. So 2 times 2 times 2 is what 2 cubed means. But then we're multiplying that by 2 squared. So that's 2 times another 2. And so notice it does work out that you end up with 5 2's. And so 2 to the third power times 2 to the second power, let me write this one more step, would be 2 to the 3 plus 2 power, which is equal to 2 to the 5th power. But I wanted you to see that when you cube it, it's literally times itself 3 times. And then when you square it, it's times itself 2 times. So then when you multiply those together, you end up with their exponents being added together, would be how you can simplify it. All right, let's look at the next rule. The next rule is called the quotient rule. So it sounds like it is, they're dividing, but we're talking about still having the same base. So x to the m power divided by x to the n power, you want to subtract their exponents this time. So think of adding goes with multiplying. The symbols kind of look alike for adding and multiplying. And then for dividing and subtracting, see how those also look alike. So that might help you remember these rules. So when we divide, we want to subtract the exponents on like bases. So let's look at an example. So if I use my same example of 2 cubed and I divide by 2 squared, let's write those out again. So 2 cubed is 2 times 2 times 2. And then 2 squared is 2 times 2. So then if you notice, when you're dividing those out, you can cancel 1 in the numerator with 1 in the denominator, because they would divide to just equal 1. And so another 1 would cancel out, and you just end up with 2. But that's also equivalent to if you subtract these exponents, that's 3 minus 2, which is just 1. And then in math, we usually don't write an exponent of 1. It's just understood to be there. So that's another good example of the quotient rule. Now let's look at 3 more rules in this video. We're going to look at power properties. So power of a power, power of a product, and power of a quotient. They all fall under the category of the power property. So the basic rule is when you have a base and it has an exponent, and then that has another power that's attached to it, you want to multiply those exponents. So I would write the base of x, and then m times n would be my new exponent. For the power of a product, it's very similar. You just need to take that exponent and apply it to both of the elements of that product. So like x times y is all to the nth power. So I sort of distribute the power and say that'll be x to the nth power times y to the nth power. And then same thing for the power of a quotient. You want to think of the x and the y both have like a 1 on them right now, and I'm going to multiply them by n. So it'll be x to the nth power over y to the nth power. But then let's look at some more examples that have some regular looking numbers, I say. So for the power of a power, let's think of 2 cubed and then is squared. So the rule says to multiply the 3 and the 2 together, because they're both in the exponent place. We got to multiply those together. So that'll end up being 2 to the 6th power. But I want you to see kind of why that works. So let's just back up for just a second. Exponent rules can always tell on themselves. So if you forget exponent rules, but you understand what a basic exponent means, you can always figure out the rules for yourself. So you can write out 2 cubed, and see the square means to write that twice. So that's really literally what squaring 2 cubed would mean. Then 2 cubed means 2 times 2 times 2. So in each of those parentheses, I can rewrite them. And then that means I have really 2 to the 6th power, because I have 1, 2, 3, 4, 5, 6 of them being multiplied together. And so that's why the rule is that you have to multiply the exponents together when there's only one base and it has more than one exponent attached to it. You have to multiply. All right, let's look at the next example. So we had power of a product. So if I have 2 cubed and 3 squared, or let's say x squared, and then that's all squared. So think of what that means. That means that I have this all is going to get multiplied by itself. So I could write it twice. And let me try to make that look more like a 2 instead of a z. So when you write it out twice, you can really see what's there. That means I have 2 times itself 3 times, and then x is being multiplied by itself, and then I have 2 3 times again, and then x is being multiplied by itself. So when you really spread it all out, again, it always tells on itself of what you should do. So you end up with how many 2's? I have 1, 2, 3, 4, 5, 6 2's. So 2 to the 6th power. Then I have 1, 2, 3, 4 x's. So notice if I had just multiplied 3 by 2, that gives me 6. And then 2 by 2 gives me 4. So you definitely, by knowing the rules, can save yourself some work. But you can also get there just by writing it all out if you need to, especially till you get used to the rules. So then when we have power of a quotient, that would be similar. Say I have 2 cubed divided by x squared. And then let's say that's squared. So you can just multiply those exponents by the power of 2. But I like to show you like why it works that way. So let's write it out again. So I have 2 cubed over x squared times itself, because that's what squaring something means. And then I have 2 3 times and x 2 times in each parentheses. So let's write those out. And then I can clearly see that in my numerator, I have 6 2's that'll be all multiplied together. So I get a 6 for my exponent. And then in the bottom, in the denominator, I have 4 x's. So I can multiply those together as well. And so if you notice back over here in the beginning of the problem, 2 times 3 gives me 6. And then 2 times 2 in the bottom, or the denominator, gives me a power of 4. So again, if you forget the rules, you can always write them out, but knowing the rules can definitely help save you some work. Here, I'm going to leave that little arrow right there. Okay. So in this video, we're going to focus on those rules only. So let's just do a few more examples of each, just to get the hang of things. So for the products rule, I have 7 cubed times 7 squared. So these are like bases. So that means I can take the base of 7 and then add 3 plus 2. And so I get 7 to the 5th power. And that's all I need to do for that one. You can type that in the calculator if you need to get an actual like larger number, or you can leave it that way. So let's see. If we did type it in the calculator, 7 to the 5th power would be 16,807. So I would just put or, because sometimes they'll just leave it as 7 to the 5th power. For number 2, we have 5x squared times x times 2x cubed. So you want to multiply your coefficients, which are 5 times 2, just like you normally would. So 5 times 2 would give you 10. And then the exponent rules go with these like bases, your variables. That's where your exponent rules come in. And so you have x squared, you have x to an understood first power, and then you have x cubed. So you just need to add the 2 plus the 1 plus the 3. Then all together, that would give you 10x to the 2 plus 1 plus 3 would be 6. So 10x to the 6th power. All right, so that's 2 more for the product property. Let's take a look at the quotient property. So we have x to the 5th divided by x to the 4th. So you want to subtract, because x to the 5th divided by x to the 4th means I need to subtract my exponents. So then 5 minus 4 will just give me x to the 1st power. So you don't just say 1, you want to keep the base, but that's just going to become your exponent. All right, let's look at number 4. We have 12x to the 5th power over 3xy squared. So you want to divide numbers like you normally would, like 12 divided by 3. The rules have not changed for that part of this problem. We have just been talking about exponent rules which go along with your variables. But 12 divided by 3 would still be 4 over 1. So you don't change the rules for that part. But then x to the 5th power divided by x to the 1st power, because those are like bases. You always want to use the ones that have the same base, and they go together. So that would be x to the 5 minus 1 power. But then y squared doesn't go with anything else in this problem, so it just stays where it is. Then let's just write that a little bit neater. So we have 4x, and then 5 minus 1 would give us a power of 4. And then 1 times y squared is just y squared, so we can just write that for the denominator. All right, let's look at a few more of the power properties. So we have x cubed squared. We just want to take those two and multiply them together. So 3 times 2 would give us x to the 6th power. And that's it for that one. Number 6, we want to use our exponent first. So like you want to take the 3 and multiply that only by the 4 for this first step. So we'd say x has a power of 4 and 3, so I need to multiply those and I get 12. But then in the next step, this is a product rule again. So then I have x is my like base, but I have an exponent on each x. So that's where you need to add them together. So then 2 plus 12 will give us 14 for our power. All right, let's look at power of a product. We have 3x squared to the 5th power. So you want to take each part of this term and take it to the 5th power. So that means we would have 3 to the 5th power, and then x would be the 2 times 5, like that would be our new exponent, would be 2 times 5. So 3 to the 5th power, we could either leave it that way or we could multiply those all together. Let's see what we got. So 3 times 3 is 9, and 3 times 3 is 9, and then we'd have one more 3. So that would be 9 times 9 is 81, and then we'd have 81 times 3. So that would be 243 if we needed to write that out. And then we have x, and then 2 times 5 would just be 10. So I would say we could do that, or we could leave it. Like sometimes they'll leave it as just 3 to the 5th, x to the 10th. But they mean the same thing. All right, for number 8, we have 5x to the 4th squared. So you just want to square both of them. So 5 squared, we can just write that, and then 4 times 2 will give us 8. And then 5 squared is 25, so we could easily just rewrite that as 25x to the 8th power. All right, just 2 more quick examples of power of a quotient. So if we have 4x squared divided by y cubed, there's actually nothing more we could do with this problem because we don't have another x on the bottom in the denominator. Actually, I take that back. I read that wrong. Excuse me. Back up. This cube, so don't make the mistake I made, is on a parentheses. So we want to think of 4x squared divided by y, but everything is getting cubed. So be careful you don't do what I just did. It did not just go with the denominator. It went with everything on the whole fraction. So then you want to cube every part of this. So I want to cube the 4, I want to cube x squared, and I want to cube the y. So let's just write that out. 4 cubed, x will become 2 times 3 for the exponent, and then y cubed, because that's an understood one that's on the original y, So it's like a 1 times 3. All right, so then 4 cubed is 4 times 4 times 4. So that's 16 times 4, which is 64. We have x to the power of 2 times 3, which is 6. And then y cubed would still be in the denominator. Okay, so sorry about that. But it shows you what you can accidentally do. So don't do what I did. Okay, let's look at one more example. If we have 2... Let me get a smaller pen. 1 second. This is just looking a little crowded. Okay. If we have 2m squared n cubed over mn, and then all of that is squared. So remember that 2 on the outside of the parentheses means everything is squared, not just the m or the n at the bottom. So then we need to make sure we square every single element that's inside of that parentheses. So that means I need to square the 2. Don't forget that one. Square the m squared, so that's m to the 2 times 2 power. The n cubed, so that's n to the 3 times 2 power. Divided by, and then the m and the n at the bottom are both going to become squared. Okay, so then we just need to clean everything up and see what else we could do. So we have 2 squared would be 4. M will be to the 4th power. N to the 6th power. Then we still have m squared and n squared at the bottom. And so what happens at this point is that's a quotient rule. So we leave the 4 and we want to subtract our exponents. So like 4 minus 2 is going to become our new exponent for the m, because they were like bases, so we need to subtract when we're dividing. And then we have 6 minus 2 for the power of n. So m would be 6 minus 2, but then nothing is going to be left over in the denominator, so we just have a 1 underneath it for right now. And when we write out our final answer, we don't need to write the 1 at the bottom anymore. So we'll have 4m, and then 4 minus 2 gave us a power of 2. And then n to the 6 minus 2 power, which gives us a power of 4. Okay, so that is enough for the first part of our exponent rules.